Hello everyone, I'm Professor Diwa, and welcome to a math video on solving quadratic equations by using the quadratic formula. Our objectives are to solve quadratic equations by using the quadratic formula, determine the number and type of solutions of a quadratic equation by using the discriminant, solve problems modeled by quadratic equations. Alright, so let's get started. First, we have the quadratic formula. It states here a quadratic equation written in the form ax squared plus bx plus c equals 0, where a is not equal to 0, has the solutions x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In the next set of examples, I'm going to show you how we can apply the quadratic formula to solve a quadratic equation. For example number 1, solve. For part A, we have 3x squared equals negative 5 minus 16x. In order to solve this equation using the quadratic formula, we need to make sure the equation is in the correct format. It needs to be written in the form ax squared plus bx plus c equals 0. So the first step is moving all the terms on one side of the equation. So I'm going to take the minus 5 and the minus 16x and move it over to the left-hand side. To do this, we just add 5 to both sides of the equation, and we add 16x to both sides of the equation. The result is 3x squared plus 16x plus 5 equals 0. Next, we can find our values for a, b, and c. A is going to be the coefficient of x squared, which is 3. B is going to be the coefficient of x, which is 16. And c is going to be the constant term 5. Next, we substitute our values into the quadratic formula. We have x equals negative 16 plus or minus the square root of 16 squared minus 4 times 3 times 5 all over 2 times 3. Next, we simplify. Inside of the square root, we have 16 squared, which is 256. We have negative 4 times 3 times 5, which is minus 60. In the denominator, we have 2 times 3, which is 6. So the result is x equals negative 16 plus or minus the square root of 256 minus 60 over 6. Next, we have 256 minus 60 is 196. So the result is x equals negative 16 plus or minus the square root of 196 over 6. Next, we could take the square root of 196, which is 14. From here, I'm going to break up the result into two separate equations. For the first equation, we have x equals negative 16 plus 14 over 6. And for the second equation, we get x equals negative 16 minus 14 over 6. Simplifying the first equation, we get x equals negative 2 over 6, which becomes negative 1/3. Simplifying the second equation, we get x equals negative 30 over 6, which becomes negative 5. So we have two solutions for this equation. We write it in set notation. So I wrote curly bracket, negative 1/3, comma, negative 5, close curly bracket. Moving on to part B, we have 1 over 4, m squared minus m plus 1 over 2 equals 0. Now this equation is written in the correct format, so we can apply the quadratic formula directly. However, it's best to get rid of the fractions. To get rid of the fractions, we just multiply by the LCD, so we multiply all the terms here by 4. Multiplying the first term by 4, we have 4 times 1 over 4 m squared becomes m squared. Multiplying the second term by 4, we have negative 4 times m is negative 4m. Multiplying the third term by 4, we get 4 times 1/2 is positive 2. And multiplying the last term by 4, 4 times 0 is 0. The result is m squared minus 4m plus 2 equals 0. Next, we find the values for a, b, and c. A will be the coefficient in front of m squared, which is 1. B is the coefficient in front of m, which is negative 4. And c is the constant, which is 2. Next, we substitute our values for a, b, and c into the quadratic formula. We get x equals minus a negative 4, plus or minus the square root of negative 4 squared, minus 4 times 1 times 2, all over 2 times 1. Next, we simplify. So on the numerator, minus a negative 4 becomes positive 4. Inside of the radical, we have negative 4 squared is 16, and negative 4 times 1 times 2 is minus 8. In the denominator, we have 2 times 1, which is 2. So the result is x equals 4 plus or minus the square root of 16 minus 8 all over 2. Next, we could simplify the terms underneath the radical. 16 minus 8 is going to be 8, so we have x equals 4 plus or minus the square root of 8 over 2. Next, we could rewrite the square root of 8 as the square root of 4 times the square root of 2. So we have x equals 4 plus or minus the square root of 4 times the square root of 2 all over 2. Next, we take the square root of 4, which is 2, so we have x equals 4 plus or minus 2 root 2 over 2. From here, we could rewrite the fraction into two separate fractions. So I wrote x equals 4 over 2 plus or minus 2 root 2 over 2. Next, we could simplify. 4 divided by 2 is 2. 2 root 2 over 2. The 2's cancel out, and then we just have root 2. So the result is x equals 2 plus or minus root 2. Next, we write our final answer in set notation. So I have a set of curly brackets, and on the inside I wrote 2 minus root 2, comma, 2 plus root 2. Next, we have a practice problem. Solve. For part A, we have 2x squared equals negative 9x minus 10. For part B, we have 1 over 6 x squared minus 1 over 3 x minus 1 equals 0. Alright, so go ahead and pause the video, try out these problems, and then check back with the video to see the solutions. Alright, so let's get started with part A. The first thing I did here was move all of the terms to the left-hand side. So I added 9x to both sides, and I added 10 to both sides. The result is 2x squared plus 9x plus 10 equals 0. Next, we get our values for a, b, and c. A is equal to 2, b is equal to 9, and c is equal to 10. From here, we substitute our values for a, b, and c into the quadratic formula. We get x equals negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 10 all over 2 times 2. Next, we simplify. We get x equals negative 9 plus or minus the square root. 9 squared is 81. Negative 4 times 2 times 10 is minus 80 over 2 times 2 is 4. Next, we have 81 minus 80, which is 1. So we get x equals negative 9 plus or minus the square root of 1 over 4. Next, we could take the square root of 1, which is 1, and then I'm going to break this up into two separate equations. The first equation is going to be x equals negative 9 plus 1 over 4, and the second equation is x equals negative 9 minus 1 over 4. Simplifying the first equation, we get x equals negative 8 over 4. This simplifies to just negative 2. So we have x equals negative 2. Simplifying the second equation, we get x equals negative 10 over 4, and then this reduces to negative 5 over 2. So we have x equals negative 5 over 2. Next, we write our final solution in set notation. So I have a set of curly brackets and negative 5 over 2, comma negative 2 inside the parentheses. Moving on to part B, we first get rid of all the fractions by multiplying by the LCD of 6. Multiplying the first term by 6, the 6's cancel out, and then we have 1 times x squared, which is x squared. Multiplying the second term by 6, negative 6 divided by 3 is 2, and then we have negative 2 times m, which is negative 2m. Multiplying the third term by 6, we have negative 6 times 1 is negative 6, and then the last term, 6 times 0 is just 0. So the result is x squared minus 2m minus 6 equals 0. Our value for a is going to be 1, our value for b is negative 2, and the value for c is negative 6. Next, we substitute our values for a, b, and c into the quadratic formula. We get x equals minus a negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 6 all over 2 times 1. Next, we simplify. Starting with the numerator, minus the negative 2 becomes positive 2. Negative 2 squared is 4. Negative 4 times 1 times negative 6 is plus 24. In the denominator, we have 2 times 1, which is just 2. So the result is x equals 2 plus or minus the square root 4 plus 24 all over 2. Next, we have 4 plus 24 is 28. So we have x equals 2 plus or minus the square root of 28 over 2. From here, we could rewrite the square root of 28 as the square root of 4 times the square root of 7. So we have x equals 2 plus or minus the square root of 4 times the square root of 7 all over 2. From here, we could take the square root of 4, which is 2. So we have x equals 2 plus or minus 2 root 7 over 2. Next, we break apart our fraction into two separate fractions. So we have x equals 2 over 2 plus or minus 2 root 7 over 2. From here, we could reduce the fractions. 2 divided by 2 is 1, 2 root 7 over 2. The 2's cancel out, and then we get root 7. So the result is x equals 1 plus or minus the square root of 7. Next, we write our final answer in set notation. So I have a set of curly brackets and 1 minus root 7, comma 1 plus root 7 on the inside. For example number 2, solve. We have p equals negative 3p squared minus 3. First, we need to put the equation in the correct form. So what I'm going to do is move all the terms to the left-hand side of the equation. This way the leading term will be positive. So I'm going to add 3p squared and plus 3 to both sides of the equation. The result is 3p squared plus p plus 3 equals 0. Next, we have our value for a is 3, our value for b is 1, and our value for c is 3. From here, we substitute these values into the quadratic formula. We get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 3 all over 2 times 3. Next, we simplify. In the numerator, we have negative 1 plus or minus the square root. 1 squared is 1. Minus 4 times 3 is minus 36. In the denominator, we have 2 times 3, which is 6. So the result is x equals negative 1 plus or minus the square root of 1 minus 36 all over 6. From here, we subtract 36 from 1, we get negative 35. So we have x equals negative 1 plus or minus the square root of negative 35 over 6. Next, we could simplify the square root of negative 35, which is I root 35. So we have x equals negative 1 plus or minus I root 35 over 6. Next, we write our final answer in set notation. So I wrote curly bracket, negative 1 minus I root 35 over 6, comma, negative 1 plus I root 35 over 6, close curly bracket. Next, we have a practice problem, solve. We have x equals negative 4x squared minus 4. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the practice problem. So first I'm going to move everything to the left-hand side of the equation. This way we get a positive leading term. So I'm going to add 4x squared and 4 to both sides of the equation. The result is 4x squared plus x plus 4 equals 0. Our value for a is going to be 4, the value for b is 1, and the value for c is 4. From here we substitute our values for a, b, and c into the quadratic formula. We get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 4 times 4 all over 2 times 4. Next, we simplify, starting with the numerator. 1 squared is 1, minus 4 times 4 times 4 is minus 64. In the denominator, we have 2 times 4, which is 8. So the result is x equals negative 1 plus or minus the square root of 1 minus 64 over 8. Next, we could subtract 64 from 1. We get negative 63. So we have x equals negative 1 plus or minus the square root of negative 63 over 8. From here, we could simplify the square root of negative 63. This becomes I root 9 times root 7. So we have x equals negative 1 plus or minus I root 9 times root 7 over 8. From here, we take the square root of 9, which is 3. So we have negative 1 plus or minus 3I root 7 over 8. Next, we're at our final answer in set notation. So I have a set of curly brackets, and on the inside, I wrote negative 1 minus 3I root 7 over 8, comma, negative 1 plus 3I root 7 over 8. Next, we have the discriminant, which is b squared minus 4ac. The discriminant tells you the number and type of solutions you have for a quadratic equation of the form ax squared plus bx plus c equals 0. Below we have a chart which tells us the number and type of solutions that result given the discriminant. So if the discriminant is a positive value, this results in 2 real solutions. If the discriminant is 0, this results in 1 real solution. If the discriminant is a negative value, then this results in 2 complex solutions, but no real solutions. In example number 3, use the discriminant to determine the number and type of solutions that exist. For part A, we have x squared plus 2x plus 1 equals 0. Since the equation is already in the correct form, we can go ahead and find the values for a, b, and c. So a is 1, b is 2, and c is 1. Next, we just take these values and substitute them into the discriminant. We get 2 squared minus 4 times 1 times 1. This simplifies to 4 minus 4, which is 0. Because the value of the discriminant is 0, this means we only have 1 real solution. Moving on to part B, we have 3x squared equals negative 2. First, we need to put this in the correct format. So I'm going to move the minus 2 to the left-hand side by adding 2 to both sides of the equation. The result is 3x squared plus 2 equals 0. Notice here that the term that normally has an x is missing. That means that the coefficient would be 0 for that term. So we have a is equal to 3, b would be 0, and c is equal to 2. Next, we substitute our values into the discriminant. We get 0 squared minus 4 times 3 times 2. After simplifying the discriminant, we get negative 24. Because the discriminant is a negative value, this results in 2 complex solutions and no real solutions. Moving on to part C, we have 2x squared minus 7x minus 4 equals 0. Since the equation is already in the correct form, we can go ahead and find the values for a, b, and c. So we have a equals 2, b equals negative 7, and c equals negative 4. Next, we substitute our values into the discriminant. We get negative 7 squared minus 4 times 2 times negative 4. After simplifying the discriminant, we get 49 plus 32, which is 81. Since we get a positive value for the discriminant, this means that we have 2 real solutions. In example number 4, an object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. The height above ground h in feet of the object after t seconds is given by the equation h equals negative 16t squared plus 12t plus 200. How long after the object is thrown will it strike the ground? Round to the nearest tenth of a second. In order to find how long it takes for the object to strike the ground, we just use the given equation h equals negative 16t squared plus 12t plus 200. From here, we just need to substitute the value of 0 in for h, which is the height of the object when it strikes the ground. So we get 0 equals negative 16t squared plus 12t plus 200. Now the equation that we have is in the correct format for the quadratic formula. However, we can make things a little bit easier by dividing all the terms here by 4. So 0 divided by 4 is 0. Negative 16t squared divided by 4 is negative 4t squared, 12t divided by 4 is 3t, and 200 divided by 4 is 50. The result is 0 equals negative 4t squared plus 3t plus 50. Next, we find our values for a, b, and c. A is negative 4, b is 3, and c is 50. From here, we substitute these values into the quadratic formula. We get t equals negative 3 plus or minus the square root of 3 squared minus 4 times negative 4 times 50 over 2 times negative 4. Next, we simplify. Starting with the numerator, we have 3 squared is 9, minus 4 times negative 4 times 50 is plus 800. In the denominator, we have 2 times negative 4 is negative 8. So the result is t equals negative 3 plus or minus the square root of 9 plus 800 over negative 8. Next, we can add together 9 and 800, which is 809. So the result is t equals negative 3 plus or minus the square root of 809 over negative 8. From here, I broke apart this equation into two separate equations. For the first equation, I have t equals negative 3 plus the square root of 809 over negative 8. For the second equation, I have t equals negative 3 minus the square root of 809 over negative 8. Starting with the first equation, I plugged this into a calculator and rounded to one decimal place. I got that t is approximately equal to negative 3.2. This value represents time in seconds, and it doesn't make sense to have negative 3.2 seconds, so we can eliminate this answer. For the second equation, I plugged this into a calculator and rounded to one decimal place. I got that t is approximately equal to 3.9. So this means after the object is thrown upward from the top of a 200-foot cliff, the object will strike the ground in 3.9 seconds. So our final answer is that the object will strike the ground in 3.9 seconds. Alright, this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.